All right, let's talk about one of the weirdest, most mind-bending ideas in all of cosmology. We're talking about an object that, for now, is totally theoretical. But, and this is a big but, it might just be the key to solving a huge cosmic mystery. And maybe, just maybe, the origin of everything.
So, where do we start? Well, it all kicks off with a puzzle. Picture this. It's 2006, and NASA's Swift satellite spots something that, according to everything we know, just shouldn't be possible. And the number one suspect for this cosmic whodunit? You guessed it, the super elusive white hole.
Okay, so like any good mystery, this one starts with a single bizarre clue. A signal from the depths of space that had scientists absolutely scrambling, trying to figure out what on earth they were looking at.
So, the first clue is a number, 102 seconds. That's how long this weird gamma ray burst went on for. Now, you gotta understand, these bursts are the most powerful explosions we know of, but they're usually over in a blink, like a few seconds tops. This thing, though, it just wouldn't stop.
And from there, the plot just thickens. This event, which got the catchy name GRB 060614, wasn't just super long, it was also insanely powerful. So naturally, astronomers pointed their telescopes, expecting to find the culprit, right? Usually that's a giant star going supernova. But they looked, and they found absolutely nothing. No exploding star, no wreckage, nothing. It was just this massive blast of energy that came from nowhere, and then, boof, was gone. Scientists were totally baffled.
All right, so when all the normal explanations just don't work, where do you turn? Well, you have to start thinking outside the box, way outside the box. Scientists started looking at a much more exotic idea, a hypothetical object that could, theoretically, create exactly what they saw. And that's where the white hole comes into the picture.
So what is a white hole? The simplest way to think about it is as the cosmic evil twin of a black hole. It's the complete opposite in every way. You know how a black hole's event horizon is a one-way street in? Well, a white hole has a boundary of no entry allowed. It's not pulling things in. It's a violent fountain, just constantly and forcefully spewing matter and energy out.
I mean, seriously, if you could take a video of a black hole sucking in a star and then just hit the rewind button, what you see is pretty much the definition of a white hole. A crazy spontaneous explosion of matter and energy erupting from a single point in space.
Now, I know what you're thinking. This all sounds like something straight out of a sci-fi movie, right? But believe it or not, the whole idea is actually based on a really fundamental principle in physics. The universe seems to have a thing for balance. The legendary Stephen Hawking talked about this all the time. He pointed out that nature seems to have an equal and opposite for everything. You know that classic rule, for every action, there's an equal and opposite reaction. The universe just seems to demand that kind of symmetry.
And you see this duality everywhere you look, right? There's matter and antimatter, hot and cold, heck, even yin and yang. So the logic kind of follows. If the laws of physics allow for something that only ever pulls things in, a black hole, then shouldn't cosmic balance mean there's also something that only ever pushes things out?
And this isn't some brand new, crazy idea somebody just cooked up. The math for black holes, that goes all the way back to Einstein in 1915. But get this. Back in 1964, a cosmologist named Igor Novikov was looking at those exact same equations and realized, hey, if you just flip some of the math around, you get a white hole. The theoretical groundwork has been sitting there for over half a century. But, of course there's a but, and it is a huge one. There's a really good reason why a lot of scientists are super skeptical and think white holes just can't exist, no matter what the equations say. The issue is, their existence would seem to break one of the most fundamental, unbreakable laws of physics. That law is the second law of thermodynamics, also known as entropy. But let's call it the broken glass rule. It's simple. You can drop a glass and it shatters into a chaotic mess on the floor. Easy. But have you ever seen all those tiny shards just decide to jump back together and form a perfect glass again? Of course not, because the universe has a one-way street. It always moves from order towards disorder, not the other way around.
And right there, that's the problem. A black hole is the ultimate endpoint of disorder. It's matter crushed into an infinitely dense point. It is the shattered glass. A white hole, on the other hand, spitting out organized matter and energy, well, that's like the glass putting itself back together. It just seems to go against the fundamental arrow of time and the very rules of physics.
Okay, so we have this massive theoretical roadblock.
With that in mind, let's go back to our original mystery, that weird signal from 2006. Does the white hole theory still have a leg to stand on as the prime suspect?
You know, when you actually lay out the evidence next to the theory, the match is kind of perfect. It was a huge burst of energy. Well, a white hole is supposed to expel energy. Check. There was no exploding star that caused it. A white hole would be a standalone event. Check. It appeared out of nowhere and then disappeared. A white hole would be a temporary fountain of matter. Check again. I mean, on paper, it fits the description perfectly.
So even though GRB 060614 is probably the best candidate we've ever found for a white hole, we just don't have the proof. The problem is we don't have the tech to get a closer look and be 100% sure. So for now, it's just this incredibly compelling piece of evidence in a cosmic cold case.
But the story does not end there. Not by a long shot, because thinking about white holes has pushed physicists to ask a much, much bigger question. One that takes us all the way back to the birth of our own universe.
Let's rewind the clock. Way back, 13.8 billion years ago, everything, our entire universe, exploded into being from a single, unimaginably hot and dense point. We call it the Big Bang. But just think about that for a second. A spontaneous, incredibly violent eruption of all matter and energy, all from a single point that just appeared out of nothing? Does that sound familiar? Because it sounds a heck of a lot like the description of a white hole, doesn't it?
And this leads to what might be the most mind-blowing idea of them all. There's a theory that a black hole and a white hole could be connected, like two ends of a tunnel through space-time, a wormhole. The idea is that all the stuff that gets swallowed by a black hole in another universe could travel through that tunnel and get shot out of a white hole, creating a brand new Big Bang, a new universe, maybe even our universe.
And that leaves us with one final, truly profound question to chew on. This theory suggests a kind of cosmic recycling program, a cycle of death and rebirth, where the end of one universe inside a black hole is actually the beginning of a new one. It's an incredible thought, isn't it? What if our Big Bang wasn't the beginning at all, but was really just the echo of another universe's end?